Hello everyone, so now we are back to review the end of year examination paper for 2022 for paper 3. So I'll be going through the structured questions for 2022 Sec 3 Express paper for Science Chemistry in this short video. So let's start with the answers for question 1. Now question 1 is from chapter 1 of your textbook. This is on measurement, instruments and techniques. So the key thing to note here is what is the quantity that is being measured? So for instance, in 1A, you're asked to measure 3 grams of sodium chloride. Grams is the unit for mass. And therefore, to measure mass in the lab, we make use of the electronic mass balance. Not the weighing scale, but it's called an electronic mass balance. Okay, so weighing scale is marked wrong. Next, for 1B, you're asked to measure exactly 31.50 cm cube of solution. So this refers to volume of a solution, and you have to measure exactly. Another word for exactly is accurately. So to measure accurate volumes of solutions in the lab, we will make use of the burette. We do not use a pipette because a pipette is only for 25 cm cube. If you are given another volume other than 25.0 cm cube, we will have to use a burette. For 1C, you are asked to collect and measure the volume of a gas. If you are collecting and measuring the volume of a gas, we will be looking at the gas syringe. So gas syringe is useful for experiments whereby you need to collect and also to measure the volume of a gas at the same time. So for instance, if you are looking at measuring the amount of product, the amount of hydrogen gas produced when an acid reacts with a metal, then you will need to use a gas syringe to measure the volume of the gas. Next, we have adding 50 cm cube of solution into a beaker. We could use a measuring cylinder for this because it does not mention there that we need accurate, exact volumes. However, for accurate measurement of 50 cm cube of solution, we can also make use of a burette. And finally, to measure the boiling point of a liquid, we will make use of a thermometer because the boiling point is the temperature at which a liquid boils. So to measure temperature, we use a thermometer in the lab. Now for question 2, you are told iron can be mixed with carbon to form an alloy. So it's always a good practice to highlight the keywords in a question. And the keywords are usually the chemical names like iron and carbon. So iron and carbon are elements which are mixed together to form the alloy called steel. So steel is made up of iron and carbon. So now we explain with the help of a diagram why steel alloy will be harder than pure iron itself. So as shown here in the diagram, we basically show atoms of different sizes. And there should not be any layered orderly arrangement in steel. So the idea is different size atoms and it's disorderly. So now in the explanation, we have to mention that an alloy like steel contains atoms of different sizes. This is because steel and alloy is a mixture of iron and carbon, so these atoms will have different sizes. When there are atoms of different sizes, it will disrupt the orderly layered arrangement of the atoms. So originally, if we have pure iron, the pure iron will be orderly and layered. However, because now there are iron and carbon atoms which have different sizes, it will disrupt the orderly layered arrangement of the atoms. And therefore, it makes it difficult for the layers to slide over one another when a force is applied. So the idea is to remember this explanation, why alloys are harder and stronger. We can remember the 3 Ds. The 3 Ds, namely, different sized atoms, disruption of the orderly arrangement, difficult for the layers to slide over one another. So the 3Ds should guide us in how we memorize this explanation. So that really concludes question 2, which is about alloys. So if you recall, alloys are mixtures containing one metal with another element. In this case, this alloy is called steel, and steel, let's recall, is a mixture of iron and carbon. Iron is the metal, carbon is a non-metal. So we mix iron and carbon to form steel. And steel is preferred, it's more useful because steel is an alloy. Alloys are harder and stronger than the pure metal because of this reason shown in 2b. So now moving on to question number 3. You are shown diagrams of particles in 6 different substances. So now we use the letters A to F to answer the questions. Now please take note, for such questions in your exam, you may use each letter once, more than once, or not at all. So there will be certain letters that are repeated in your answers. There may also be letters which are totally not used after answering all the questions. So please be mindful of this. There is no need to cancel out and use every single letter once, because you may use each letter once, more than once, or not at all. So now if you look at the arrangement of the particles, you will come to the conclusion the answers are D, B, E, F, C. Now first, for part A, you are told it's pure oxygen. Pure oxygen is diatomic. What it means is that 2 atoms make up a molecule of oxygen, so O2. So we have to look for an element where there are 2 atoms joined together. Okay, so D is the best answer because D is an element. There is only one type of circle, one type of atom inside D. So we know D is an element. Moreover, D is a diatomic element. The 2 atoms which are identical are joined and combined together, so it's O2. Next, we go to pure water vapor. Now, pure water vapor, water is H2O, it's a compound. So now we will look in A, B, C, D, E, F for a compound where there are 2 hydrogen atoms, 1 oxygen atom, and that's B. All of the particles in B are H2O. Next, we move to E. Okay, a mixture of elements is E. You can see that E is a mixture of elements. Okay, there's 1 element, 2nd element, 3rd element. So E is actually a mixture of 3 different elements. F is a mixture of compounds. There's 1 compound here, another compound here. So we say that F is a mixture of 2 compounds. And finally, a mixture of elements and compounds can be found in C. You can see element. You can also see another element. And you can of course see a compound in C. So C is a mixture of elements and compounds. So we need to be familiar with how to differentiate from these diagrams elements and compounds and mixtures. So if you are still unclear about how to do this question, please refer to the previous video on Chapter 2, Kinetic Particle Theory and Elements Compounds Mixture. So in the Chapter 2 video, I go through once more how can we differentiate elements, compounds and mixtures based on the diagrams of their particles. So a reminder, this is Chapter 2. So if you are lost, you can revise Chapter 2's video in the same playlist. So now moving on to question 4. Now question 4, this is the fractional distillation method. You can tell it's fractional distillation because there is a fractionating column. Okay, so the method is called fractional distillation. This is covered in the chapter 1 of the textbook, as well as the chapter 1 video for the revision playlist. Now, another key clue that tells you it's fractional distillation is that they gave you the boiling points. You can clearly see we have two different liquids, ethyl acetate and acetone. Both have different boiling points, and therefore, the mixture can be separated using this technique because they are miscible liquids with different boiling points. The meaning of the word miscible means can be mixed. So ethyl acetate and acetone, they mix together. They can be mixed together. We say that they are miscible. Now, besides that, more importantly, these two chemicals have different boiling points, which allows them to be separated by fractional distillation. So the key learning point here is any two liquids, or three liquids even, with different boiling points can be separated by fractional distillation. Now for parts B and C, what's the purpose of the thermometer? I think that's quite clear. It is to measure the boiling point of the liquid that's boiling off, that's being collected. The distillate that's first collected, this word distillate. Distillate simply means the liquid that boils off. So distillation is about getting the liquid to boil off and then later it's condensed. So identifying the distillate that's first collected, so we look at the boiling points. So acetone is collected first in this case because it has a lower boiling point of 56 degrees Celsius. And finally, why must boiling chips be added? It is to ensure smooth boiling of the mixture. So the idea of boiling chips is really to ensure the boiling is not overly violent, because boiling results in a lot of bubbling and that could cause a flask to crack if there were no boiling chips. So boiling chips ensure smooth boiling. And finally, in order to ensure that the distillate doesn't evaporate and escape, we can actually place the conical flask which contains the distillate at the end into a beaker of ice, also known as an ice bath. So what this means is the conical flask at the end can be dunked into a beaker of ice. Alright, and this allows the distillate to be cooled down so that it doesn't evaporate away as quickly. Alright, so these are the answers for question number 4. And this, if I may remind you, is in chapter 1 of the textbook. You can also refer to the chapter 1 revision video for separation techniques so that you can revise it as well if you have forgotten the contents here. Now we shall move on to question number 5, the next question. Remember, you may pause the video at any point if you should need more time to go through the concepts, and I will highly urge you to go back to the revision videos for every single chapter in this playlist to revise. Now we go to question number 5. Now question number 5 involves isotopes as well as ions. You may refer to the chapter 3 revision video for isotopes and atomic structure. You may also refer to the chapter 4 and 5 revision video for ionic bonding. So these chapters come together during your revision, so please revise them together. So now we start with 5A. You are told that there are phosphorus atoms and phosphide ions. So you are given the two numbers associated with phosphorus in the periodic table. So let's remind ourselves. The smaller number, 15, is the proton number, whereas the larger number, 31, is the mass or the nucleon number. So the proton number is 15, therefore the number of protons will just be 15. Okay? Now, to get the neutrons, we will take the larger number, which is the mass number, minus the smaller number. So 31 minus 15. That gives you 16 neutrons for both of them. So now the only difference is between an atom and an ion. So you can clearly see that the ion is charged. The charge is 3 minus. The 3 minus charge is on the ion. 3 minus means it has gained 3 electrons. Remember, electrons are negative. When you gain the electrons, you become more negative. As a result, the P3 minus ion has 18 electrons. Because at first, the atom has 15, you gain 3 electrons, it becomes 18. Okay, which makes sense because 18 electrons works out to 2, 8, 8 in terms of electronic configuration. So the outer shell is fully filled when you gain the 3 electrons. So that's 3A. If you are lost about 3A, please go back to the chapter 3 revision video on atomic structure. Now we go to B part 1. Explain how and why magnesium atoms form magnesium ions. So the idea is the how and the why. So we need to say magnesium atoms have an electronic configuration of 282. And so they will lose 2 valence electrons. This is the how. So magnesium atoms, they have 282 electronic configuration and therefore they lose 2 valence electrons. And what this does is that it allows them to achieve a fully filled outermost shell. And that's the why. Okay? So the how refers to the loss of the 2 valence electrons. The why is to achieve a fully filled outermost electron shell. Again, this belongs to chapter 4, ionic bonding. So again, if you have forgotten this, please watch the chapter 4 and 5 revision video in the playlist. And now, we will move forward to B part 2 and B part 3. Now, B part 2 and B part 3 continues the ionic bonding. So the chemical formula for magnesium phosphide is obtained by looking at the charges. Magnesium is in group 2. As mentioned in the previous part, it loses 2 valence electrons to form Mg2 plus ions. Phosphide is P3 minus as given in part A. So the idea is to balance the positive and negative charges. Whenever you see 2 and 3 in the charge, you need to know that, okay, we need to work towards their common multiple. The lowest common multiple of 2 and 3 is 6, meaning I need to have 3 times of magnesium, 2 times of phosphorus in order to make 6 plus 6 minus to balance each other's positive and negative charges out. Therefore, the formula is Mg3, 3 magnesium, P2, 2 phosphides. Okay? And finally, you're asked to compare the electrical conductivity. So now if you recall from the chapter 4 revision video, electrical conductivity means you need to look at whether there are free moving or mobile ions. So we have to consider if the ions are free to move or not. So in the solid state, we have learned from kinetic particle theory, in the solid state, the ions are in fixed positions. Okay, so the ions in the solid state are held in fixed positions by strong electrostatic forces of attraction between the ions. Because they are held in fixed positions, this means they are not free to move to conduct electricity, and therefore solids do not conduct electricity for ionic compounds. On the other hand, the moment you have melted it, molten means melted, liquid, the strong electrostatic forces of attraction between ions have been overcome, and therefore the ions in the molten state are free to move to conduct electricity. Okay, so it's all about whether the ions are free to move or not. And just a reminder, magnesium phosphide must be an ionic compound. This is ionic compound. We are able to deduce this because magnesium is a metal, phosphorus is a non-metal. So recall that metals react with non-metals to form ionic compounds because metals lose electrons, non-metals gain electrons. So these form ions with charge. Then they attract each other by strong electrostatic forces of attraction between the ions. So up to this stage, really is the video from chapter 4 and 5. Now let's move on to the next page. The next page is about isotopes. So you are now told there are two different isotopes, phosphorus 31, phosphorus 32. Explain why they are considered isotopes. So actually, they want you to define what is meant by isotopes. So if you recall, isotopes are atoms of the same element, same number of protons, but different number of neutrons. So what I've highlighted in blue thus far is the definition of an isotope, which you can obtain from the chapter on atomic structure, chapter 3. However, when you are given specific data, you are told it's phosphorus 31, phosphorus 32, that's specific. If you are given specific data, it's very important to state the data. Meaning, you should state how many protons they have. So both phosphorus 31 and phosphorus 32 have 15 protons. It's the same number of protons, 15. You can see that because the proton number is 15 for both. Alright? Besides that, they have different number of neutrons. You can calculate it. So you can calculate that phosphorus 31 will have 16 neutrons, whereas phosphorus 32 will have 17 neutrons. So it is important, if you are given specific data, to go into the specific details in your answer by calculating the number of protons and neutrons as well. Now we shall skip question 6. Question 6 is on group 17, which will not be tested for the end of year exam for 2024. So we will skip question 6. And we will proceed to question 7. Now once you read question 7, you highlight keywords. Keywords meaning chemical names. Now besides chemical names, another group of keywords that you should definitely highlight are numbers with the units. So you can see 25 cm cube of hydrochloric acid. Besides that, excess is also another keyword. The word excess means a lot, extra. This means that iron 2 carbonate, I've added a large amount of iron 2 carbonate such that it's in extra. Okay, so in chemistry, we don't say extra. The proper chemical term is excess. So in 7a, you're asked to explain what is meant by the term acid. So an acid is a substance that produces hydrogen ions, H+, when dissolved in water. So it is very important to take note that for an acid to produce H+ ions, it has to be dissolved in water. Next, you're asked how to state how the pH value changes. Now, as the acid is being reacted away with iron 2 carbonate, there's less and less acid. If there's less and less acid, the pH should increase. If you recall, acid, hydrochloric acid, has a pH of 1. And therefore, as the hydrochloric acid is reacted away, the pH should go up, increase towards 7, because as the hydrochloric acid reacts away, it produces iron 2 chloride solution. Iron 2 chloride should be neutral. So if you add universal indicator in part C, the color of the solution will be green. And the reason is because all the acid has reacted away, leaving behind a resulting solution, which is neutral. Okay, so this concludes 7A, B, and C. Now, one reason why we should always highlight the chemical names is because the chemical names immediately allow us to work out what the reaction is. So in this case, iron 2 carbonate and hydrochloric acid. So this is acid plus carbonate. Acid plus carbonate produces a gas. And the gas produced, of course, if it's a carbonate, the gas produced is CO2 gas. So we have to make these links in our head. When you read the word carbonate, it means that it produces carbon dioxide. So the gas is carbon dioxide. So how do we test for it? So in 7D, you're asked to describe the test for carbon dioxide and the expected observations. And in 7E, you are asked to write the balanced chemical equation, which you can now see on the screen. Now take note, the word iron 2 means iron has a 2 plus charge. So it's Fe2 plus. Carbonate is CO3 2 minus. Chloride, chlorine is from group 17. It has 7 valence electrons. It will gain 1 more, so it forms Cl minus. So you can see the formula is written as such. If you have forgotten how to write all these equations and balance them, or if you have forgotten the acid reaction with carbonate, please revise the chapter 8 revision video on acids and bases. This revision video in chapter 8 also covers the reactions, the gas tests, as well as how to write balanced chemical equations. And now, let's move on to question number 9. So question 8 is also out of syllabus. This is on salt preparation, which has been removed from the syllabus for combined science. So question 8, we will skip. Now we go to question 9. Now question 9 is about the heating curve. You can find this in the chapter 2 Kinetic Particle Theory revision video, as well as chapter 2 of the textbook. Now, the heating curve allows you to quickly work out what's the melting and boiling points. The melting point, boiling point. Melting, boiling. Basically, we will look out for the regions of the heating curve which are flat, horizontal. So you can see the melting is P, the boiling is R. So P occurs at a temperature of 0 degrees Celsius. This means that this substance melts at 0 degrees Celsius. On the other hand, R, boiling occurs at 100 degrees Celsius. So the boiling point is 100. So melting point, boiling point as labeled on the y-axis. So this must be water. Water has a melting point of 0 degrees Celsius as well as a boiling point of 100 degrees Celsius. Next, you're asked a very standard question. What are the processes taking place at P and R? Melting and boiling. So again, we are able to tell that it's changing state because the temperature remains constant. The temperature is flat at the regions. So always look for the flat, horizontal regions of the heating curve. That will tell you that there's a change in state happening. Next, you're asked another standard question. Explain why the temperature remains constant. This is a very standard explanation which you can get from the chapter 2 revision video. Okay, at region R, that's where it's boiling, so that's the boiling point. During boiling, all the heat energy that is taken in is used for overcoming the forces of attraction between particles. Therefore, there's no change to the kinetic energy of the particles, and so temperature remains constant. So this reminds us temperature. This concept of temperature is actually proportional to the average kinetic energy of the particles. So in this case, because there's no change to the kinetic energy of the particles, the temperature will remain constant. So this again is a very standard question which is asked in kinetic particle theory. Part D. A student deduces that this substance is a mixture. Explain why this student is incorrect. Now, if you look at the heating curve, the melting point is 0. It's fixed. The boiling point is 100 degrees Celsius. It's also fixed. So a fixed melting and boiling point tells you that the substance is pure. On the other hand, mixtures are impure. If they are impure, mixtures do not have a fixed melting and boiling point. So it is very important to relate melting point, boiling point fixed as pure. So you can test for the purity of substances by looking at whether they have a fixed melting point or boiling point. Again, this is covered under the chapter 2 revision video for kinetic particle theory as well as elements, compounds and mixtures. So if you remind yourself, mixtures are impure. Elements and compounds are pure. Okay? Moving on to part E. So now we sketch the cooling curve. Cooling curve basically is just a reflection of the heating curve. So you go down from 120 to minus 20. Alright? Marking out the boiling point as well as the melting point. And finally, F. You are told that this substance has a melting point of minus 218, boiling point of minus 183. A good way to do this is to label these melting point and boiling point of substance W on a number line. When you do this, you divide your curve, your number line into 3 segments, solid, liquid, gas. So now you ask yourself, minus 200. Minus 200 is in between minus 218 and minus 183. Therefore, it's a liquid at minus 200. On the other hand, 0 is all the way to the right-hand side of this number line. Right-hand side means gas. So we draw particles arranged in a liquid state at minus 200 degrees Celsius and particles arranged in the gaseous state at 0 degrees Celsius. So whenever you have negative numbers, please use a number line to represent the melting and boiling points and then work out what is the state of the substance at different temperatures. This is very crucial to avoid yourself making a careless mistake. So this concludes question 9, which is based off chapter 2. Now we can move on to question 10. Now question 10 is based off acids and bases. Therefore, this is chapter 8. So again, you may wish to revise chapter 8's revision video. Now, question 10 tells you to describe 3 reactions of acids. Now, another way to say reactions, they could have asked you for chemical properties. So when we ask you for chemical properties, what we mean by that is a chemical reaction. Now, this is different from physical properties. Physical properties have to do with taste. Acids taste sour. Color. Acids turn moist blue litmus paper red. Acids turn universal indicator red, orange, or yellow. So physical properties are things that you can observe with your 5 senses. Sense of taste, sense of sight are 2 of them. So taste and color are physical properties, whereas chemical properties refers to reactions. So these are the 3 reactions of acids. Acid with metal, acid with base, acid with carbonates. Now next in part B, you are told sodium sulfate can be prepared by reacting sodium hydroxide with acid Y. So you got to ask yourself, which acid is this? Remember, the acid always influences the anion, the second part of the salt's name. So the second part of the salt's name comes from the acid. It's the back part that comes from the acid. So sulfate comes from sulfuric acid, which has the formula H2SO4. So writing the balanced equation for this reaction, sodium hydroxide is NaOH. So NaOH plus H2SO4 forms sodium sulfate. Now sodium sulfate, please write the formula carefully. Sodium is in group 1, so it's Na plus. Group 1 elements form Na plus 1 charge. Sulfate, SO4, 2 minus. And therefore the formula of sodium sulfate is Na2SO4. This is so as to balance off the positive and negative charges. Now to balance the equation, I need a 2 in front of the NaOH, 2 in front of the H2O. So it is very crucial that you balance the equation slowly. The first step is always to write the correct formula. The correct formula meaning NaOH, H2SO4, Na2SO4. These are the correct formula. Once the formula are written correctly, then we add numbers in front of the chemicals to balance the equation. If you have forgotten how to balance the equations, again, please refer to Chapter 8's revision video. Okay, and that concludes question 10, because part C is on salt preparation, which we will not cover because it's out of syllabus. And now we shall move to question number 11. Now, question 11 goes through types of oxides. So again, the types of oxides, they are basic, acidic oxides, as well as neutral and amphoteric oxides. So we know that sodium oxide is basic because sodium is a metal. Metal oxides are mostly basic. Carbon dioxide. Carbon is a non-metal. So carbon dioxide is acidic. For the neutral oxide, an example could be carbon monoxide. So we have gone through this. Monoxides of non-metals are neutral. Of course, besides carbon monoxide, you could have written water. H2O, another monoxide, neutral. The last one that is neutral, nitrogen monoxide, NO. So we can remember this as the CONO hole. Okay, the three neutral oxides, CONO hole. And finally, amphoteric oxides. Amphoteric oxides, there's zinc oxide, aluminium oxide, lead-2 oxide. So we remember it as ZEP. Zinc, aluminium, and lead are metals which form amphoteric oxides. And just a reminder, this word amphoteric means that the oxides can react with both acids and bases. So amphoteric oxides are able to dissolve in both HCl and NaOH, for example. Okay, so if you have again forgotten the types of oxides, this is chapter 8 of your textbook. You can also refer to the chapter 8 revision video where we also went through these 4 types of oxides along with examples. Now, we move from the types of oxides, which is chapter 8, we move on to bonding. So this is chapter 4 and 5, drawing dot and cross diagrams for ionic compounds and covalent compounds. So now we have sodium oxide. Immediately, you need to know this is ionic. It's ionic because sodium is a metal, oxygen is a non-metal. Then you go to the periodic table, you realize sodium has 11 electrons. So it's 281. If it's 281, it has 1 electron in the outer shell. It will lose 1 electron to become 28. When you lose negative electrons, you become positive. So it's Na plus. On the other hand, oxygen, 8 electrons to 6 is its electronic configuration. 6 valence electrons. Therefore, we gain 2 more to achieve a fully filled outermost shell. You gain 2 electrons. Electrons are negative, E minus. You gain 2 of them, you become 2 minus. Highlight the plus, highlight the minus. Ask yourself, are the plus and minus already the same? Do they already cancel each other out? The answer is no. Plus 2 minus. Therefore, I need 2 sodiums for 1 oxygen. Therefore, the formula is Na2O. Hence, you must ensure you have 2 Na plus with 1 O2 minus. You are only asked to draw the outer shell electrons. Therefore, we only draw the 8. So instead of drawing 2, 8, we just draw the 8 in the outer shell of Na plus and O2 minus. Lastly, please take note, electrons gained. The electrons gained by your non-metal like oxygen must be in a different symbol. So I started with a cross to represent electrons of oxygen. Now I need to use a dot to represent the 2 electrons that oxygen had gained. Which makes sense because these 2 electrons had come from sodium itself. Sodium lost electrons, oxygen gained electrons. Effectively, sodium has transferred its valence electron to oxygen. This is the concept of ionic bonding, a transfer loss and gain of electrons. So now we move from sodium oxide, metal plus non-metal, ionic compound. We move to covalent substance, carbon dioxide. CO2 is definitely covalent because both are non-metals. Because they are non-metal plus non-metal, it's covalent. Covalent means sharing of valence electrons. Carbon goes into the center because there's only one carbon atom. You always choose the atom that is fewer of it in the molecule. There's only one carbon atom, so put it into the center. The next step is oxygen is at the sides. We overlap the shell. How do you decide that you must share this many electrons? We look at oxygen at the side. Oxygen, 8 electrons. The electronic configuration is 2, 6. 6 outer electrons. It needs 2 more. So if you need 2 more electrons, you must share 2 electrons. Sharing 2 means this. I share 1, you share 1. I share another 1, you share another 1. So sharing 2 electrons means dot, cross, which is why you see dot, cross in the shared overlapping region. And finally, you need to make sure that the outer shell is fully filled. Fully filled means 8 electrons. So oxygen needs to have 8 electrons, therefore there are 4 more crosses, 4 more electrons outside to ensure the outer shell has 8. So this is how we draw dot and cross diagram for a covalent substance. If you have forgotten this, let's go back to the chapter 4 and 5 revision video in the playlist on ionic and covalent bonding to revise. And finally, we have B. Okay, B is on metals, copper, magnesium, and zinc. Okay, we reacted them with steam. We collected and measured volume of gas within first 10 minutes. So this is a reaction of metal plus steam. So a metal reacting with steam produces the metal oxide plus hydrogen gas. So I'm actually measuring and collecting the volume of hydrogen gas. But do all metals react with steam? The answer, of course, is no. Copper is unreactive with steam. Because copper is at the bottom of the reactivity series, it doesn't react with steam. Therefore, there's no gas produced. Okay, so the one with 0 cm cubed should be the unreactive metal, copper. So you learn that this is related to reactivity. Therefore, the most reactive metal, which is magnesium in these 3 metals, should produce the most gas. And therefore, we obtain these answers: copper, zinc, magnesium. Finally, now that you know that metal plus steam forms the metal oxide and hydrogen gas, so magnesium metal, magnesium solid, metals are solids mostly. Steam is H2O but gaseous, very important. So the gaseous, the state symbol G tells you that this is steam. So magnesium plus steam forms the solid magnesium oxide, MgO, and hydrogen gas, H2 gas. Okay, so if you have forgotten the reaction of magnesium plus steam or metals plus steam, okay, if you have forgotten the reactions of metals, this is chapter 12, the reactivity series. So please revise this revision video for chapter 12 as well as chapter 12 notes that have been given to you in class on the reactivity series if you have forgotten how metals may react with steam, water, or acid. And this concludes the review of the 2022 EYE paper. Thank you very much.